A warm greeting to all of our respected faculty. My name is Vijith Poojary, and with my teammates Varun Shiri and Vinayak Majati, we have developed a restaurant queuing application. The purpose of this application is to build an online system that enables you to book a table at a restaurant to avoid the hassle of waiting in queues. Now, as far as managing queues in restaurant is concerned, when your stomach is grumbling, the last thing you want to do is keep waiting to eat, because the hungrier we get, the grumpier we get. Which is why restaurants that don't have an effective queuing strategy risk scaring off customers and ultimately hurting their business's success. Restaurants are unlike other businesses in that the customer's mission is to make a purchase and get out as fast as possible. They want to sit, chat, socialize, and eat, all while having a pleasant experience. And the major part of that pleasant experience has to do with restaurant queues. Now, why do restaurants need to care about queues? Sometimes businesses can feel immune, especially restaurants. If there's a line out the door, then they must be doing something right. But long queues over a long period of time ultimately hurt business. How exactly? Well, some ways are more obvious than others. Customers become fed up with waiting and leave the restaurant for a competitor. Negative experiences mean negative reviews are posted online. A lost customer will probably never return. While quarterly profit is typically seen as a measure of success, customer satisfaction holds equal weight. It costs 4 to 10 times more to acquire new customers than it does to retain existing ones. That means a restaurant that builds a loyal customer base is likely to be more successful than a restaurant that needs to constantly attract new customers. Plus, happy customers want to share their positive experiences with friends and family, and even complete strangers, thanks to social media. This inclines additional customers to eat at your restaurant, effectively proving the power of word of mouth advertising. If restaurants want to foster a customer experience that keeps customers coming back for more food, they have to learn how to reduce customer waiting time. Now, how to manage waiting customers? Waiting rooms are a typical element of eating at a restaurant. But just because waiting is a typical part of eating out doesn't mean impatient customers can be ignored. These soon to be paying patrons are just as valuable as customers who have just signed on the dotted line. And one of the ways of managing waiting customers is adopting a restaurant queue management system. There's a simple solution to help you with most queue management issues. That is a queue management system. It's the easiest way to reduce customer waiting time. Many restaurants have adopted a token system. Waiting customers hold on to an electronic box. Once it beeps, they know it's their turn to be served. But even these tokens are outdated. They're cumbersome to monitor and risk being lost or broken. But perhaps more importantly, they seem redundant in a world where almost everyone is carrying a smartphone. At the same time, QMS, that is the queue management system, enables restaurants to alert customers when it's their turn to be served through an SMS alert or a notification alert or a simple text message. Doing so frees up customers to busy themselves however they want in the meantime. Want to grab a drink at the bar or window shop at the mini mall nearby? You're free to do so without being afraid of missing your lunch. Since the restaurant delivers accurate waiting times thanks to their efficient time organization, customers know exactly how long they have to wait. They are not plugged into a small hallway with other customers waiting to be served. Some restaurants are notorious for their long waiting times before being seated and served. But this image can be scrubbed. Adopting the aforementioned tactic to be better understand how to manage queues will greatly help any restaurant reduce customer waiting time. Now, as far as this application is concerned, there are certain requirements, that is functional and the non-functional requirements. Let's take a look at the functional requirements. Number one being the user must be able to check the availability of tables, that is number of tables available or free at a particular restaurant or a restaurant of his choice from the choice of from a list of restaurants which are on his screen, on his cell phone or his system. The user must also be able to reserve or book a table at a particular restaurant or a restaurant of his favorite choice by providing some personal details like his name, email, or his phone number, and the size of the group with whom he is coming, who he or she is coming with, or the size of the family. The user must get a notification of his place in the queue and an estimated time to be seated. The administrator or the hotel admin must be able to log into the dashboard and allot free tables of available size to the customer of the size which he has mentioned, for which he has made a reservation. The following are the non-functional requirements. The server hardware can be any computer capable of running both the web and database servers and handling the expected traffic to make sure that the server doesn't crash. For a small scale restaurant that is not expecting to see much web traffic, an average personal computer may be appropriate. Once a site starts generating more hits, though, it will likely be necessary to upgrade to a dedicated host to ensure proper performance. The exact cutoffs will need to be determined through a more thorough stress testing of the system. Now we'll be taking a look at the artifacts which are used to design the system, which will be explained by my friend Vinayak Majati.
Now we will look into the artifacts of our project, going from firstly the class diagram. In software engineering, a class diagram in UML is a type of static structure diagram that describes structure of a system by showing the system's classes, their attributes, operation, and the relationship among the objects. We have divided the class diagram in two phases, that is login and the queue class diagram. In login class diagram, we have the manager class, user class for login info with controller to validate and login storage to store the details. Going on to the next, we have the queue class diagram. In queue class diagram, the user interface class relates with restaurant class, leading to the book a table class, where the attributes listed deals with the booking info. Going on to the next artifact, that is the use case diagram. In software and system engineering, a use case is a list of action or events, steps typically defining the interaction between a role, that is, as an actor, and a system to achieve a goal. The actor can be human or an external system. In our software, as shown, we have two actors, that is the manager and the user, where manager have the access to table allot page and both user and manager have the access to booking details login page, and user has a list of restaurants where he is allowed to book a table. Going on to the next artifact, that is the sequence diagram. A sequence diagram shows object interaction arranged in time sequence. It depicts the objects involved in the scenario and the sequence of messages exchanged between the objects needed to carry out the functionality of the scenario. The functionality in our software require to book a table and get the booking details and place in queue. This sequence diagram depicts exactly the same sense given a time sequence with which the estimated time is delayed, where actor searches for a keyword to search a restaurants and it then displays a restaurant list, and user can select a restaurant and book a table into it by giving the order info, and the software replies back with the order details, that is the number in queue and the estimated time. Moving on to the next artifact, that is the activity diagram. activity diagram is essentially an advanced version of flowchart that modeling modeling the flow from one activity to another activity. Our project's flow goes from user to book a table if the restaurant is full, then going back to choose a different restaurants. Otherwise, or else showing the place in a queue that estimated time in booking details. On the other hand, the manager being able to allot a table and have the booking details accordingly. Moving on to the next artifact, that is the ER diagram, the entity relationship diagram. ER diagrams helps to identify different system entities and their relationship with each other. Information as inside oval shape are attributes of a particular entity. In this software, we have four entities, namely customer, manager, restaurant, item, and booking. Discussing relations among the entities, we have customer views the restaurant and places a booking, and manager has restaurants and takes bookings, and lastly restaurants contains items in the menu. Now moving on, my friend Varun will explain about the test cases and demo of the project. Thank you.
Now let's look at a live demo of our application. So we have built it using React on the front end and Node.js on the back end. So our application mainly has two user flows. The first user flow is that of the customer, wherein you have a list of restaurants and the customer can book a table at a restaurant he wishes to go to. And the other workflow is that of user flow is that of an admin dashboard, that is where the restaurant manager can view and manage all the bookings. So let's first look at the admin workflow. So each restaurant will be provided with some login credentials through which they can access their dashboard. So now let's look at the dashboard for roll call. So as you can see over here, uh, the restaurant manager can view all the bookings that have been made, and also the tables and their availability. So over here we already have two bookings that have been made, and two tables have been allotted respectively. So now let's go ahead and make a booking in this particular restaurant. But before that, let's just have a brief overview of how our algorithm works. So whenever a booking is made, our algorithm checks all the tables to see if there is any free table with a capacity that is greater than or equal to the group size. And if it is so, it will allot a table. But if a table is not available, then the customer's booking will be pushed into a queue. And as the admin frees a particular table, and that is when the customer finishes his meal and pays the bill, then this particular table will be freed. And then our algorithm again checks for uh, the remaining bookings in the queue to see if any booking can be allocated to that particular table. So let's make a booking in the same restaurant, roll call. So ideally, we would have different time slots over here, but now we are assuming just one particular time slot. So the user needs to enter his details and then he can book the table. So then he gets a booking ID, which is a unique ID for his booking. So as you can see here, we already had one table which was free, but now, so that is why this particular customer was not queued. So this table with a capacity of 2 was allotted to this customer, and so he can directly proceed to the restaurant. Now let's go ahead and make another booking and see what happens now. We've also implemented form validation to ensure that the details are correctly entered. So as you can see here, now there are no tables available over here. That is why this customer has entered into a queue and he's been given a queue number, and also the booking has been updated over here. So let's make one more final booking in the same restaurant. As you can see here, now he gets a queue number of 2, and we've also given an estimated waiting time. For now, we've assumed that each position in the queue would give you a waiting time of 60 minutes, and he also has his unique booking ID. If we look at the dashboard, his booking is entered over here. Now let us free a particular table and see how and the next booking is allotted to this table. So now as you can see, this particular booking with the ID 6627 has been automatically allotted to this table because it satisfies this capacity fits within this group size. Now let's free another table, and before that you can see that the position in the queue has been updated and also the estimated waiting time. So now Suresh is at the first position in the queue, and now if we free another table over here with the capacity of 2, you can see that his booking has been allocated to this particular table, and over here his status has been updated saying that your table has been reserved and you can proceed to the restaurant. So in conclusion, we saw the two user flows that our application has. So one, a customer can book a table from a list of restaurants by entering his particular details, and he's updated with regard to the position in his queue and the estimated waiting time. And the other flow we saw is that of the admin, the restaurant manager, where he can view all his bookings and also manage the bookings. So we believe that this application can help you avoid the hassle of waiting in long queues at a restaurant without knowing when you're going to get a table, especially on days when there is a lot of crowd. And we're living in a fast-paced world today, so time really matters. So we believe that this application can help you save your time, and we believe that it can benefit both customers and also restaurants, because restaurants can manage their tables in the process through our application. So this was our attempt at automating the process of restaurant bookings. Thank you.